Okay, hello. We're getting started here of the first lesson that we're going to be recording. I'm going to be recording, and we'll go through several of these through the semester. But I want to touch base with you and say, hey, uh, with some fundamentals. This first section, this first topic I want to talk about touches on several different things I'm going to ask you to do throughout the semester. It's going to include questions, similar questions, related questions on the first quiz, on the first test. It's going to be on the final exam. So it's something to get down in a solid way. And I want to go to it now. So anyway, let me go over to my iPad and let's take a look at that and verify. Now, one of the things I'm going to ask you to be engaged with me on several of these situations is it's kind of hard to do at long distance, but I want you to be thinking, okay? Be thinking. And even if you just think to yourself the answer I'm asking of you, just think it and see if I can pick up the vibe. Okay, so let me ask you this. What do you need to determine the slope of a line? What do you need to determine the slope of a line? Yes. See, now there's a handful of you that thought it so strongly that I heard you. I felt the vibe. You know what I'm saying? Yes, 2 points. You need 2 points to determine the slope of the line. And one of the things, if you look at the iPad I have here, the equation for slope is equal to the change in y over the change in x. That delta, it means change in, typically in mathematical terms, change in y over change in x. So sometimes if we got a y2 minus y1 over x2 minus x1, that's a typical equation for the slope of the line. You need 2 points. Well, one of the things that we're coming into here is, notice I used m for slope. And, what do you think of when you think of the equation of a line? What's the first thing that comes to mind? If you think of letters to represent the equation of a line, what comes to mind? Yes, once again, I heard you. Y equals mx plus b, where m is the slope, I heard it, and b is the y-intercept. So that is something that we're going to be working with. I'm going to ask you to write equations of lines throughout the semester and determine the slope. But what's interesting about this calculus is one of the things that we're being drawn to. Let me switch over to a different screen here. Let me go to the text that we have here. When you have a tangent line to a curve, one of the things that we can do with calculus, a tangent line to a curve, means it touches at one point. And it touches at one point. You can see the slope of this line, tangent line, okay, is pretty close to, where is it 0 on this graph? Where is the slope equal to 0? Yes, it's where it's level. And then right about there, that looks like the slope is 0. And also down here, the slope is 0. And notice in between, it was going from left to right as we move to the right. That means the slope is going down and it's negative. Slope is negative in between. Slope is positive to the left. Slope is negative in between. And slope is positive to the right. And it's 0 here and here. Or hither and thither. Or here and there, I guess. That's another way of saying here and there. But here is here and there is there. Okay, but one of the situations I want to get across is we recognize that you need to determine the slope of the line having 2 points. Well, what calculus allows us to do is, what if we only have, what if we only have 1 point? Can you tell the slope of the line? And there's a way to do that. And what we're going to do is discuss that a little bit here. And what I want to show you is this. They've got some neat dynamic software. It's kind of cool here. One of the things they're pointing out here in the text, I'm getting this from the text, is that, where we drew a line through a single point, P, and the tangent line touches at 1 point. These three also touch at 1 point, notice, but they wouldn't be called tangent to it because of the fact that it fits certain, it's got a certain where it touches at 1 point only, but it's also got some other characteristics about it. We'll show you that right now. So before defining a tangent line, we investigate its slope. It's what's saying right here. So we want to find out the slope of this line, let's say. We'll talk about the tangent line in just a second. But the slope is discussed in the appendix of the book. You can click on that, books in the top right corner a little later. But what we've typically said is if you've got two different points, then the slope of the line between those 2 points is the value of x. If at some point C, we have x equal to C, and then f of x is equal to f of C, the y value. This is the x value, this is the y value. And then if you've got another point x and y, x and f of x, and c and f of c, well, what it's called a secant line, which is it crosses the curve at 2 points, more than one. And the circumstance is that what we can do is determine the slope of this line using our definition of slope, change in y, f of x minus f of c, over x minus c, the change in x and the change in y over the change in x. That'll give us the slope of that line. And then check this out, the dynamic geometry, the software is kind of cool here. Here's the idea, that if you start up here at fx and f of x, then we've got this line, the slope of that tangent secant line, the slope of the secant line is the change in y over the change in x, where f of x minus f of c over x minus c. Well, as we get closer, and then we bring a little bit closer. We bring a little bit closer, so notice the x is coming in here. X is coming in here, and it reaches a point here where there's a different x, x sub 2, let's say. It's getting closer. The slope of this line, the secant line, is closer to the slope of the tangent line, but it's still quite a ways away. It's closer than it was from that first line, but it's still quite a ways away. So let's get a little bit closer. Sounds like a song, doesn't it? Get a little bit close. Okay, so the situation is that you end up with getting a little bit closer to that tangent line. And the idea is the distance between x and c is getting smaller and smaller. And as this distance gets smaller, we get closer to the slope of the tangent line, okay? Until we reach a point, we're getting really, really close, until you get to the point where you're right on the tangent line. So the distance between x and c gets smaller and smaller, okay? Well, when we're talking about here, one of the terms we're going to be discussing is the idea of a limit. And notice what it's saying down here. As x gets closer to c, as x gets closer to c, what we want is the slope of this line. And we don't know it, because we need 2 points. All we've got is 1 point. But if we can tell that the slope, as we're getting closer and closer, as x is getting closer and closer to c, the limit as x approaches c of that relationship here is getting closer and closer to the slope of this line. So you notice that the slope of the tangent line, notice what this definition is saying then. The limit as x approaches c of the change in y, f of x minus f of c, over the change in x, which is x minus c. The limit as x goes to c of this, that is the slope of that tangent line, okay? And there's some real neat characteristics of this. This is when you start to use calculus, we're getting to the idea of a derivative. And the idea is this: the tangent line is, look what it says here. The tangent line to the graph of a function at the point CF of C is the line containing the point P whose slope is, the slope of the tangent line is equal to the limit as x approaches C. So notice that it's getting closer and closer in that early diagram of all these different lines that are going through. This doesn't meet that criteria. It's got to get closer and closer and closer to this tangent line. And so the limit as the x approaches 0 of that, that's the idea of what we're finding. And the idea of the limit as x approaches c, right here, the limit as x approaches c of this difference is going to be the slope of that tangent line, okay? That is a key point I want to get across. And we'll discuss this again in just a little bit. I'll make point to bring it up again. But right now, that's all I'm going to say for the first lesson, okay? Go back over that a couple times if you want to. But the idea is, this is getting the limit definition of what a derivative is. We're going to be talking more and more about this, and I'm going to be asking you to calculate it, and we're going to be going from there, okay? So what I'm going to do right now is just going to close this and get ready for a next lesson, and I hope you can just keep smiling, and we will go from there, all right? Be well. I will get back with you shortly. Look at the next section coming up, the next lesson.